Hello friends, so today we will study an interesting problem which is the boolean parenthesisation problem. So what is the statement of this problem? Let us see. We are given a boolean expression with following symbols: T for true and F stands for false, and we are given three types of operator in this particular version of the problem. First is the AND operator, which is the boolean AND. Second one is the boolean OR, and third one is the boolean XOR. I hope you all know what AND, OR and XOR are. So with that understanding, let us come to the problem statement. We want to count the number of ways in which we can parenthesize the expression. Parenthesize means we need to put some brackets so that the value of the expression is true. So our aim is this: the value of expression must be true. So for a crystal clear understanding of the problem, let us take an example. Let us say this is the symbol array, which is true, true, false, true. This is the operator array, which is OR and XOR. It may be anything: OR and OR, it may be AND, it may be OR and OR, anything. So this OR basically comes here. What it denotes is this OR comes between these two trues. This is the 0th element, this is the first, this is the second, this is the third, if we consider zero indexing. So this OR must be placed between these two. This AND must be placed between this true and this false, the first and the second element, and this XOR must be placed between false and true, this. So we can't change any order. So these must come in this order, these must come in this order, and these must be placed between them. So true or true and false XOR true, true or true and false XOR true, true or true and false XOR true, true or true and false XOR true. All are same. What is the difference between all these four? The difference is quite simple. How the parentheses are placed. The brackets are here and here in this one, here and here in this one, here and here in this one. So there are many permutations and combinations in which we can place these brackets, but not all those placings will result in the final value to be true. So what our aim is? Our aim is this: the final thing, the value of this final expression should be evaluating to true. So all these values are true. So this particular expression, the expression if pronounced will be same, but just the way we place these brackets is different in these four, and there can be many more, but they result in false values, so we don't consider them. Our aim is to count those placings of the brackets which result in a final value of true. So this expression, which is represented by these two arrays, evaluates to true in four possible ways: this one, this one, this one, this one. Okay, so this was the problem. Let us see how to solve it. We try to deduce a formula to solve this problem. Now we will create a formula to solve this problem, and later we will discuss about this problem in detail. So let Ti, j represent number of ways to parenthesize the symbols between index I to j, so that the resulting expression evaluates to true. Then Tij is equal to this. So this expression looks quite lengthy, but it is very, very simple if we analyze it. So let's analyze what this means. We take k from I to j minus 1. So k is the breaking point. We want the expression from I to j, index I to index j. So we divide it into two halves, two parts at kth index, and we will vary k, but let's assume k to be fixed for now. So ti comma k is the first half and tk plus 1 comma j is the second half. And then what our aim is, this is the first half and this is the second half, and between these two halves an operator will be placed. Which operator will be placed? The kth element of the operator array, because it is still k and it starts from k plus 1. So between these two, kth element of the operator array will be placed. You can just see this analogy here. This is the 0th element, this is the 1, this is 2, this is 3, and this is 0, this is 1, this is 2. So between 1 and 2, the 1th element of this operator array is placed. So between k and k plus 1, kth element of the operator array is placed. I think now you understand. Between 2 and 3, 2th element of the operator array is placed. I think this makes the things crystal clear. Now let us come again to this thing. Okay, so this operator is being placed. So the kth operator, if it is AND, boolean AND, then the number of ways in which this whole expression from ith index to jth index can be true is, the expression from I to k evaluates to true, the number of ways, multiplied by the number of ways this also evaluates to true, the k plus 1 to j. So the number of ways in which k plus 1 comma j, expression from k plus 1 to j evaluates to true is tk plus 1 comma j, and the expression I to k evaluates to true is ti comma k. So this evaluates to true and this evaluates to true. There is an AND in between these two. So we multiply by following the basic rules of permutations, because this and this must be true. There is no OR in between. So this is if the operator k is, the kth element of the operator array is AND, and if the kth element is boolean OR, what we do is total I comma k. What is total I comma k? The total number of parenthesizations, total number of ways in which we can put brackets between index I to index k, that is equal to true and false sum, because either it will be false, it will either, or it will be true. So total minus when both evaluates to false. So I think the multiply part is clear. So total minus when both evaluates to false. This is for OR, because OR is false only in this case. In all other cases it is true. So we deduct this case from it for the final expression to be true. Now let us see the third case. Ti comma k. So XOR, when is XOR true? When first is true, second is false, or first is false, second is true. So these two halves of the expression are like that. But there is, let's come to the outer part. Why are we varying k from I to j minus 1? Because we assumed the partition to be at k, but now k can also vary. Just see. So we consider k from I to j minus 1. K can also vary from I to j minus 1. And the base case here is, this is the recursion formula and this is the base case. Ti comma I is equal to 1 if symbol I is equal to true. If the ith symbol is true, there is no way in which we can parenthesize actually. So if it is true, then Tii is equal to 1. From ith to ith index, it can be parenthesized. Actually it can't be parenthesized, so that the value evaluates to true. It is one way, because it is always true, and 0 way in which it can be parenthesized, so the value can be false, because we can't get the value to be false if it is, the symbol is true, T, and the opposite for F. So I hope you understand these things. So similarly we derive the formula for the Fij, but you can just note it down after pausing the video, but I think this is left as exercise for the user because the video is getting too long. So we will discuss more about this problem in the next lecture. Thank you, friends.